Okay, sorry, this is going to be a two-parter video. Sorry, I hit stop by mistake. Okay, so this point right here and this point right here, okay, they're both on their way up, where this point right here, let me choose a color a little different, okay, this point right here and this point right here are both on their way down. So these ones here are going to be 15 seconds away from each other because that is our period. And these ones here are going to be 15 seconds away. So just pay attention to that because sometimes you'll have questions where they're asking you where each of them are, and you just want to be careful with that. So they are not, the pink to here, that's not going to be your 15 seconds. Here to here is going to be your 15 seconds. Okay, let me clear all that. And so now, if I was doing it on Desmos as opposed to my calculator, I can just come here and click. And I see, oh, 3.12. And here, see how it's 15 seconds further on the up and another 15 seconds further. Okay, now if I'm doing the ones on the down, this is 8.1. This is 8, hold on, let me see. Let me get rid of these for a second so I can see the ones I'm on. Sorry, too many going. Okay, so this one was 8.1. And on the way back down over here, that's 15 seconds. And again, as I'm coming and then I'm going back down, this one is going to be another 15 seconds. So just understand the relationship with that. Okay, so enough about that now that I have 2 videos going for this. Okay, so let's go to the last problem. I'll try not to press stop in this problem. Okay, so a maximum height of 14 meters occurs at 3 a.m. and a minimum height of 6 meters occurs at 9:15 a.m. Let Y be the depth of the water and T be the number of hours after midnight. Sketch the sinusoidal curve. Okay, so at 3 a.m., so starting here, this is midnight, 1 a.m., 2 a.m., 3 a.m., and so forth. Okay, this is, and when I say that, it's really hours after midnight. So at 3 a.m., which is 3 hours after midnight, we're up at 14, and 14 is going to be a high. So let me just kind of maybe draw that in, that this is going to be a high here at 14, okay? And so, and we also know that a low is going to occur at 6 meters. So I can also get my low at 6 meters. Now, if I'm looking at that and my high is 14 and my low is 6, I can go 14 plus 6 divided by 2, and that would average them. That's going to be 20 divided by 2, which is 10. So my center, my vertical shift is going to be at 10. Okay, so I can see my amplitude. I can see my vertical shift. I know that at 3 a.m., I'm up at 14 meters. So 3 a.m., I'm going to go up to 14. Okay. I don't know what the whole period is. I do know when I have my low. My low is going to be at 9:15. Now, that's time. We want hours. So that's going to be 9 hours. And then the 15 minutes is really 15 out of 60, which is 1/4 or 0.25. So really I'm at 9.25 hours, okay, is where my low will be. So I'm going to come to 9.25. I'm going to zoom in a little so I can see that a little better. And I want my low. And so my low is going to be about here, let's say. Okay, and I'm going to put numbers here so I know like where I am. So I'm going to put here that this is at 3,14. This one down here is 9.25, 6. So even though I don't know my period, if I know from here to here, I know that the same distance is going to go this direction. So if I take this difference between 9.25 and 3, so let me just do that math over here. And get a different color. So I'm going to take 9.25 minus 3, and I get 6.25. Okay, I'm going 6.25 this way and 6.25 this way. So if I wanted to know where I'm ending at, okay, I can add 6.25 onto this. So I could take 9.25, which is where my low is, add 6.25, and I end up at 1550. So I'm going to go to 15.5, 15.5, and that's going to be my high, and that's going to be at 15.5, comma 14. Okay, now if I want to figure out halfway between here is going to be a 0. When I say 0, my vertical shift height of 10, and then halfway here. Okay, I don't need to necessarily figure that out unless they're asking me to. So I know that, let me just get my graph drawn here. And if I want to be more accurate with these points, I can, but I think we're fine like this unless they're asking us. But if I come up with the equation, I can always find it from my equation. So now for this, I want to find all the pieces. I know my A, okay, it's 10 to 14, so my A is going to be 4. I know my K is going to be 10. I know I'm starting here at 3. If I'm doing cosine, I personally would do cosine for this. Okay, they gave us a choice, I would do cosine. So for cosine, my H is going to be 3. Okay, it's going to be an X minus 3 is what I'm going to have here. Now my B, I know it's 6.25 to here and 6.25 to here. So what that means is if I take 6.25 and I double it, I end up with 12.5. That is my period. And I know that 2 pi over b is equal to 12.5. And so now I'm going to do that math. So I am going to, I'm going to do it right here. When I cross multiply and solve, I end up with 2 pi over 12.5 equals b. Now, I'm not going to put the pi in my calculator, but I'm going to see if 2 divided by 12.5 is nice. 2 divided by 12.5 it actually is a 0.16. If I wanted it as a fraction, it's 4 over 25. So I can either do 4 pi over 25 or 0.16 pi. Okay, so I have two choices here. I can either do 0.16 pi or 4 pi over 25. Both of those end up being the same. So that's my B. So now I can write my equation. Again, I personally would write it as a cosine. So I'm going to write y is equal to, my amplitude is 4 times cosine of, and you can either put it in as this or this. I think I'll put it in as the fraction here, 4 pi over 25 times x minus 3 plus 10, and that's your equation. If you wanted to write it as a sine, you would need to figure out this value. So you want to average 9.25 and 3, because it would be halfway in between those is where my 0 would be. So 9.25 plus 3, I'm going to divide that by 2, and I get a 6.125. So this point right here would be at 6.125 comma 10. And so if I wanted to do a sine graph, now if I'm doing it from here, pay attention, I'm going down, so it would be negative. So this would be y equal -4. Amplitude is always the same, but sign might change. When I say sign, I mean positive or negative sign. Sine, everything else besides our phase shift is going to be the same. So I can still write 4 pi over 25. Now, instead of this being an x minus 3, it's going to be an x minus 6.125, x minus 6.125, and then I have my plus 10. Okay. Now, that's where we stopped in class today. So I'm going to stop us here, and then we'll do the rest. Or you can stop here. I'll continue the rest of this, but this is what we did. I'll continue the rest with this, but we did stop here in period 1. Okay. So if I'm continuing on, okay, for our next class, calculate the depth of the water when t equal 2. You can choose whichever one you prefer. I think this one's a nicer one to do. And I keep writing x's. They are saying t. I'll put a t here. I'll put a t here. Okay, t. So when t is 2, I'll put 2 in here. And then when we have 2,100, I'll put that in here. Okay, so let me compute that real quick. So I just put in the 3 into the t here. You can see it right there. And I ended up with 13.5. Okay, about 13. Okay, so that was 13.5. I'm going to do the same thing, but now I'm going to enter in 2,100. Now, just to clarify with this is not really 2,100, this is 2,100 hours, okay? So what this means is we're 21 hours after midnight, okay, is where we're at. So I'm going to put a 21 in here. So I'm just going to re-enter this, and I want a 21. Now, I don't want to hit my 1 in. Let me get this back on for a second. Sorry about the glare. I want to actually, on the delete button is the word insert. So if I want to put my 1 in here and not have to retype everything, second and delete for insert. My cursor looks a little different, and now I can put my 1 in, and I can hit enter, and I get 6.28 or about 6.3 feet. Okay, 6.3 feet. So now it says, write down the maximum depth of the water in the harbor and calculate the value of T when the water is first at its maximum depth during the day. Okay, so the maximum depth of the water was our 14. Okay, that was our 14 feet. That was the maximum depth. Calculate the value of T when the water is first at its maximum depth of 14 during the day. So I am going to put in y equal 14 along with, I'm going to enter in this equation, okay? And I'm actually going to do it on Desmos, so let me just get that in. So I entered in the equations here into Desmos, so you can see here is my equation. I also entered in y equal 14. Now this again is one we could see from our graph, but here you can see every time it's at a height of 14, a maximum depth of 14, okay? And again, we're adding on our period of 15.5 every time, okay? Or actually not 15.5, what was it? It was 12.5 was what it was, right? 12.5. So I'm adding 12.5 each time. Now, again, here, we could see that max height of 14 right here at 3, but not always can you see it, so that's another way of doing it. So we're going to end up with this at 3 hours. Okay, it ends up at 3 a.m. Then it says the harbor gates are closed when the depth of the water is less than 7 meters. An alarm rings when the gates are opened or closed. How many times does the alarm sound during the day? So we want to figure out how many times is the water less than 7 meters. Okay, that's what we're looking at, less than 7 meters. Okay, so less, my highlighter, sorry. Less than 7 meters is what we're looking at. So if I'm looking here, okay, here is 7 meters. So I want every time it's less than 7. So as I'm going, okay, anytime it's from here to here, and then on the next one, that's what I'm looking at. So I'm going to go back to my graph. Okay, let me get it back up for us. I'm going to change this to a 7. And here I can see that at 7.812 and then again at 10.688. So in between here, this is when it's going to be closed. Over here again, when it's 20.3 hours and 23.3 hours. So let me just get a pen here. So again, it's as I'm coming across, 1 time right there, 2 times it's going to ring, 3 times, 4 times, and we're trying to see this. Let me get rid of the pen for a sec. So we're trying to see this. Oh, that wasn't helpful. Okay, so what I just added in here, I added in x equal 24 because we want how many times in a day. So that's within 24 hours. So I just have this line here in orange so I can see. So you can see it's going to be 1 time, 2 times, 3 times, 4 times that's going to happen from 0 to 24 hours. So that's what they're asking us on that question when it says, how many times a day does the alarm sound off? So let me get back to that screen. Okay, and that's where I'm looking for it. And so this is going to be 4, oops, highlighted, 4 times. And it says find the value of t when the alarm first hit. So if I'm back looking at this graph, so the first time is right here, and that's going to be at about 7.8 hours. Okay, 7.812, but about 7.8 hours. So again, right here, find the value of t when the alarm first sounds. 7.8 hours about is when that's going to happen. And then it says, use the graph to find the length of time during the day when the harbor gates are closed. Give your answer in hours to the nearest hour. Okay, so we want when it's closed. So let me get back to the graph. So we want to know how long during the day. So I need to figure out this distance, and I need to figure out, not distance, but this length of time. Okay, so the first time that, let me get out of the pen. Okay, try this one more time. Technical difficulties today. So I want the distance from here to here. Okay, so I'm going to click here without moving anything. That's 7.812, 10.688. I'm going to come over here and I'm going to do that math. Let me get those numbers again. So 7.812 and 10.688. So 10.688 minus 7.812. So that's going to be 2.876. That's going to be this distance from, not distance, but the time here. And we don't have it once, we have it twice. These should be the same time. So I'm going to then come up here and take that answer, 2.876, and times it by, get my times it by 2, and I end up with 5.75, and they wanted us to round it to the nearest hour, so that's going to be 6 hours. Okay, so that's going to be 6 hours. So again, the math I did was I took the two values from the time it closed and opened back up, so 10.688, and I subtracted it from 7.812, and I ended up with 2.876. I had this is how many hours it was closed for the first closure, and we have that twice in the day, so times 2, and that's going to be 6 hours when we round to the nearest hour. Okay, so that's the second video for today.